Okay, so we've got a seriously fascinating mystery unfolding right now in the world of AI news, and honestly, it's got developers pulling their hair out. If you've been following the latest in developer tools, you might have noticed something off. Recently, Aggregate metadata analysis revealed a highly specific anomaly inside OpenAI's Codex. We're talking specifically about the GPT 5.5 model here. People have been trying to figure out why the world's most advanced coding AI is just, well, suddenly breaking down on complex tasks. And it turns out the answer seems to be hiding deep down inside the model's telemetry data. Let's dive into it. Picture this. You're relying on a top-tier AI assistant for some critical software architecture. You give it a prompt, and then you just watch it stall out. It starts guessing wildly and eventually crawls to an absolute halt. It's incredibly frustrating, right? Recently, users have been reporting that both GPT 5.4 Fast and GPT 5.5 Fast have become extremely sluggish. We're talking about waiting 10 to 30 seconds before it even generates a single token. And then, it streams at a painfully slow pace of 1 token per second. The crazy thing is, this isn't even happening on massive code bases. It's happening on small prompts and entirely new sessions. The frustration out there in the community is very real for sure. Just look at this report from GitHub user Bosco J 2008. They pointed out that high-stakes coding requests are completely failing, leaving users stuck waiting for super simple commands, like a basic grep, to execute. I mean, users are actively noticing that while older or different models can complete these tasks without a hitch, Codex seems to just go on vacation mid-thought. It's literally just checking out. So what exactly is causing this massive headache? Well, developers and researchers started digging into the metadata logs, and they found a bizarre, highly specific smoking gun. It's a seemingly random number, exactly 516 reasoning tokens. Now, this isn't just some random fluctuation or statistical blip. What we're actually looking at here is being called the 516 clustering anomaly. See, normally you'd expect a natural dynamic variation in an AI's thinking time, right? It should adapt based on how complex the task is. But instead, the AI is hitting a hard-coded wall. The data shows responses are disproportionately terminating at exactly 516 reasoning tokens. And it doesn't stop there. There are secondary spikes at exact multiples of that number, like 1034 and 1552. Basically, the system is forcing the model to just short-circuit its logic at these exact numerical boundaries. Okay, so how does this hard-coded wall actually trigger real-world failures? Well, there's a perfect example in GitHub issue #29353. Users tested this simple candy logic puzzle, one where the shapes can be distinguished by touch. Now, in a healthy run, the model used thousands of reasoning tokens, provided detailed step-by-step commentary, and nailed the correct answer, which is 21. But in an anomaly run, it generated exactly 516 reasoning tokens, provided absolutely zero commentary, confidently stopped thinking, and spit out the completely wrong answer of 29. It's like when the token budget runs out mid-thought, the AI just bluffs the rest of the way. What makes this whole anomaly even stranger, honestly, is the timeline, because this definitely wasn't always happening. If we look at the data spanning from February to June of 2026, and this is across tens of thousands of response records, the exact 516 anomaly just exploded. It went from a tiny fraction of a percent, about 0.11% in February, all the way to over 53% of all measured responses by May. Over half. And this sudden, massive spike coincided exactly with a noticeable drop in overall reasoning token intensity, which basically means the AI simply stopped thinking deeply about the problems it was given. The data actually proves this is an aggressive structural limitation that is directly tied to the newest model families. Just look at the numbers. GPT 5.5 hit the exact 516 cap in 44% of sampled records. GPT 5.4 hit it almost 20% of the time. But if you look at older models like GPT 5.2, it only exhibited this exact behavior 0.34% of the time. So this tells us pretty clearly that we aren't looking at a general platform bug. This is a highly specific, localized behavior baked right into the 5.5 model architecture or its routing logic.
So why exactly does a token cap completely break the AI? To understand that, we need to talk about what machine learning researchers call emergent abilities. These are complex capabilities, things like multi-step reasoning and in-context learning, that only really show up when large language models reach a massive scale. And here's the kicker. They rely entirely on continuous, uninterrupted chains of thought. Doing complex debugging or mapping out dependency graphs requires sustained reasoning. If you arbitrarily chop off that thought process at 5116 tokens, that emergent reasoning ability just shatters into a million pieces.
And this is exactly why developers are sounding the alarm everywhere. From GitHub to Reddit, developer Lionel233 put it perfectly. He noted that sure, simple syntax fixes might work totally fine under a 516 token budget, but your multi-file refactors, your critical security audits, those are failing silently. The model is forced to output a conclusion before it actually completes the logical derivation, which means it hands you back incredibly confident but fundamentally flawed code. It's a real game changer, and not in a good way. As you can imagine, the community isn't just sitting around. They are scrambling to fix this themselves while waiting for an official patch. Users have been testing all sorts of wild workarounds. Some folks have actually found success by messing with the core system prompt, literally stripping out the intermediary update section to try and stop the AI from quantizing its reasoning. Others are building these incredibly complex custom JSON-L ledgers. It's basically a way to force the model to pick up where it left off by injecting a continue thinking marker into the backend. And honestly, a lot of people are just throwing their hands up and falling back to older, more stable models. Now, if we zoom out a bit, this whole metadata anomaly points to a much larger structural tension happening right now in the AI industry. It's all about scaling laws. Scaling laws essentially dictate that as these AI models get bigger and smarter, they need vastly more computational resources to run. What we might actually be seeing here is the sheer immense financial and computational cost of running these massive models. It might be forcing providers to implement really aggressive behind-the-scenes cost optimizations just to keep the lights on. And you know that agonizing 1 token per second slowdown we talked about earlier? Well, this orchestration overhead is exactly why users are experiencing it. As one really insightful developer pointed out, the true bottleneck here might not even be model inference latency. Instead, we're likely looking at massive orchestration overhead. The infrastructure is desperately trying to manage resources, handle dynamic routing, execute tools, and compress context all at the exact same time. The system might literally be artificially capping reasoning budgets just to keep the servers from melting down under the immense load. So, what's the big takeaway for us today? Well, until this scheduling bottleneck is officially resolved, you absolutely need to protect your workflows. Keep a close eye on your CI/CD pipelines and actively query your metadata payloads. Look specifically for exactly 516 or 1034 reasoning tokens. If you see those numbers pop up on a complex task, you know for sure the reasoning was likely truncated. You've really got to implement fallback routing to older models for those high-stakes jobs. Force explicit maximum length constraints in your API calls. And always ask the model to validate its own work step by step. It really leaves us with a massive question for the future of developer tools, and honestly, the future of generative AI itself. Are we simply hitting a temporary speed bump in the infrastructure routing, or is this the hidden cost of finally hitting the ceiling on AI scaling? I mean, if these models have to be silently throttled just to keep the ecosystem from collapsing, we might have to seriously rethink how we rely on AI for complex, high-stakes logic going forward. Thanks so much for joining me on this explainer, and seriously, keep a close eye on your metadata out there.